Welcome guys, welcome to my YouTube channel Learning Links. In this video we are going to learn how to solve for individual currents through each of the resistors in a parallel and series combination of resistors. So in this circuit we observe that this 8 ohm and this 5 ohm resistor, these are in parallel. So in parallel the 1 by R equivalence is equals to 1 by R1 plus 1 by R2. So 1 by R equivalence is equals to 1 by 8 plus 1 by 5, and that is 40 by 13 ohms. And if you want a detailed explanation of it, I have provided a video in the links in the description. You can go and watch that. I have taken the same circuit as an example, so you can watch that and come back to this video. So I will not concentrate more on the calculate equivalent resistance. I will calculate only the current passing through it. So now this 40 by 13 ohms and this 4 ohm resistor are in series. So in series we know that we can directly add up the resistors and we get the equivalent resistor. So this 40 by 13 ohms changes to 92 by 13 ohm resistors. Now this 92 by 13 ohms and this 3 ohm resistor are in parallel. We use the formula and this changes to 276 by 131 ohms. Now this 1.80 ohms and this 276 by 131 ohms are in series, so we have to directly add them. As we have to add them, one of them is in decimal, so I will take this also in decimal. So 276 by 131 is approximately 2.106 ohms. Now if we add them, we get 3.906 ohms. So now we have the R equivalence of the total circuit. So we have to find the current through this resistors, this R equivalence. So we will use the Ohm's law to calculate the current flowing through this. According to Ohm's law, the voltage of a circuit is equals to the current times the resistance. So voltage here is 12 ohms and current we don't know, and the R equivalence we found is 3.906 ohms. So if we divide by 3.906 on both sides, this gets cancelled and the current we get is 3.072 amperes current flow through this resistor. Now if we move to the previous circuit, the circuit which was before this circuit, that was 1.80 ohms and 276 by 131 in series. Now we know that the current flowing through this is 3.072 amperes. As the 1.80 and this resistor are in series, so the same current 3.072 will flow through this also, as the current is constant in a series circuit. So if we move to the previous circuit, this 276 by 131 ohm resistor was the parallel combination of some two resistors. The resistors were like this. So the current, the same current which is coming here, 3.072 amperes, will not flow through both of them because they are in parallel. In parallel, the current is not constant through them. So we have to find the voltage across both of them to find the current through them. So we have to find the voltage across this 276 by 131 ohm resistor. So we know by Ohm's law V is equals to IR. The voltage we have to find, the current through it is 3.072 amperes and the resistance is 276 by 131 ohms. So voltage, if you put that in a calculator, we get 7.799 volts. So the circuit becomes something like this. The currents through the 1.80 ohm resistor is this one, and the current through this is this one, and the voltage across this resistor is 7.799. So if we move to the previous circuit, which was the combination of these two resistors, 92 over 13 and 3 ohm resistor, the voltage across both of them we just found now, that is 7.799. As the voltage is constant across a parallel connection, so the same voltage will apply on both of them, which I have indicated with a blue line. So now we have to find the current through each of them. We know that V is equals to IR by Ohm's law. So voltage across them is 7.799 equals current we have to find through them, and the resistors is 92/13, and I equals 7.799 by 92/13, and that comes out to be 1.102 ampere. So the current through this one is 1.102 amperes. Now we have to find the current through the 3 ohm resistor. So we know voltage equals current time resistors by Ohm's law. Voltage across that is same, 7.799 volts, and the current we have to find through it, current through the 3 ohm resistor, and the resistor is 3 ohms. So current equals 7.799 divided by 3, and we get 2.599 amperes. So the current through the 3 ohm resistors is 2.599 amperes. Now this 92/13 ohm resistor was a series combination of 2 resistors before this. So it was 40/13 ohm resistor and a 4 ohm resistor in series. So the same current which we found earlier, which was 1.102 amperes, will be shared across both of them. So we get 1.102 amperes on the 40/13 ohm resistor here, and also on the 4 ohm resistor, and here we found that the current was 2.599 amperes, and the current here is 1.102 amperes here and here, as both of them are in series. Now we know that in the next circuit, the circuit which was before this circuit, this 40/13 ohm was a parallel combination of 2 resistors. So now again we have to find the resistance, the voltage across this resistor, because in parallel the current is not constant. In parallel the voltage is constant across the resistors. So we will use the Ohm's law, V equals IR. V we don't know. I, the current through it is 1.102 amperes, and the resistor is 40/13 ohm resistor. So we have to multiply that, and we get the voltage equals 3.3907 volts. So the voltage is 3.3907 volt across this. Now we move on to the previous circuit, the circuit which was before the circuit. So it was a 8 ohm resistor and 5 ohm resistor in series. So the same voltage we found there, 3.3907, is across both of these resistors because they are in parallel. In parallel the voltage is constant. So now we have to find the current through them. So voltage equals current times resistance. As the voltage is 3.3907 and the current we have to find out, and the resistance is 8 ohms, we get current across the 8 ohm resistors to be 3.3907 divided by 8, and that is 0.423 amperes. And we have to find the current through the 5 ohm resistor, that is voltage is equals to current time resistance. Voltage is the same, 3.3907 volts, and the current we have to find out, and the resistance is 5. So current we get 3.3907 volts by the resistance 5, and if we divide that we get 0.678 amperes. That is the current through the 5 ohm resistor, and that's how we find the current through each of the resistors. Thank you guys. I hope you like this video. Please like, share, subscribe to our channel. Thank you.